Welcome to this session. And in this session, we'll be discussing about the examples based on non-homogeneous heat equation. So I hope you are thorough with the solution of the heat equation. I'm sorry, non-homogeneous heat equation, as discussed in my previous video. I'll attach the link in the description. So in case you haven't watched, please do watch it and then proceed for this video. Okay, so I'll consider one example. Yeah. So let's consider problem number one. Let's say you got ut equals, it's for any general c, and ux plus some sine of 3 pi x. All right, and then I have my ux 0 equals my sine pi x, the sine of pi x, and I'm giving initial conditions to be ut equals 0 and u of 1 comma t is also 0. Okay, then find out what is uxt. So we need to find out the solution. Also find what happens when limit t tends to infinity u of half ft. Okay, so the solution goes like this. See, whenever you get this problem, you need to first identify what is your function and initial condition and boundary conditions. So boundary conditions I already have. That's u0 to h0, u1 to h0. And here I have got ux0 to be sine pi x. So as I discussed in my video, that the ux0, the initial condition is your function pi. Okay. And here it was supposed to be a function of x and t both, but since this is already a function of x, but still we will consider it to be function of x and t. Okay. Because as per our standard heat equation, that's what we have discussed, that is utt equal to uxx plus some f of xt. Okay. In that case, our f of xt is this. All right. So the solution, okay, solution is given by, let me write down the formula. Solution is given by uxt equals to, okay, the standard heat equation, that is n equal to 1 to infinity d, and then sine of n pi x over l e power minus c times n square pi square upon l square to t, plus some extra terms which are coming from this non-homogeneous part, and it will make it to n equals 1 to infinity, and then sine of n pi x over l, and then this entire integral, this thing will come into integral from 0 to t and e power c times n square pi square upon l square into t, and then this is multiplied by fn of s ds. Okay. Please make a note that it is fn of s ds. It's multiplied. Okay. The solution is given by this equation. Now we will just find out what is dn and fn. Okay. So dn stands for to be 2 by l integral 0 to l phi of x into sine of n pi x over l dx. Okay, and my fn of t is given by 2 by l integral 0 to l. Here it will be f of xt. Okay, and then sine of n pi x on l dx. So we are ready with the formula now, and we will solve it. Okay, so let me consider the solution. Oh, instead of writing the solution, let me just first evaluate dn. Okay, so dn will be given by 2 over l is 1, so it will be simply 0 to 1 phi of x. Phi of x is this quantity, sine pi x. So it will be written here sine of pi x into sine of n pi x. L is 1, so no need to worry. Now here we have got a problem because the formula that we know works only for the limits 0 to pi. Okay, 0 to pi sine mx into sine nx dx. This equals pi by 2 when m is equal to n, and it is 0 when m is not n. Okay. So So in order to apply this formula, we need to change this integration limits. So in that case, I can make a substitution, a simple one. So let me just erase this part and I'll make a substitution in there right here. Okay, so let me consider this. And here it goes. So one can see very carefully if I put pi x to be equals to some other variable. So I'll be putting this. So put pi x equal to z, my all-time favorite. And then, so as x tends to 0, okay, z will tend to 0. And when x tends to 1, my z will tend to pi. And now differentiate, so you get pi dx equal to dz. So our integration now becomes, it will be just simply 2 times and then integral 0 to pi. Now it will become sine z and then sine of n z. What is dx? From here you get dx equal to 1 upon pi dz. So you get dz and here you get 1 by pi. So basically you get here 2 by pi and then this integration will exist only when n here becomes 1. Okay. So basically I'll be getting just d1. The rest of them will be 0. So we can pi by 2. So proper cancellation gives me 1. So I'll say that dn is equal to 0 for all n greater than. Okay. And d1 I have. So I found d1. Now my goal is to find out this fn of t. Okay, so let's find out it. So fn of t equals 2 by L is 1. So I won't write it. It's 2 times integral 0 to 1 f of xt. F of xt is this variable, sine 3 by x. Sine of 3 by x into sine of n by x over L is 1. It will simply dx. Now, again, I have to change the limit. So by the same ideology that which we have applied earlier, I'll put pi x to be t, and then my limits will be changed to 2 by pi integral 0 to pi. It will be sine 3z to sine of n z d. Okay. And now you already know that here it is n, it is 3. So this integral will be existing only for n equal to 3, and for rest of them it will be 0. Okay, as per our previous formula, so it will be f3t. So that will give me 2 by pi. Then this integral will also be pi by 2, which again gives me 1. Okay, so luckily I got f3t, and I have to write down a note that f of t equal to 0 for all n excluding 3. Okay. And our goal is now just to substitute in the formula. So just let me call this a big one, the big guy. So let's consider now from star. Well, I did not name this equation. Oh, I'm sorry, I've named it. From star u of xt. First, I'll simplify the formula and then write down the solution. Okay, summation n equals to 1 to infinity. See, since I know that it will work only for dn. Okay, still our job is to write down. So n by x, no need to write L now. Okay, and e power minus of c is not given. Okay, it's any arbitrary c, so we have to keep c intact. Into the picture, it will be simply c n square by square t and plus summation n equals 1 to infinity sine of n by x into e power c times. I think I guess I made a mistake here. It's not t, by the way. Okay, just let me recall again. Yeah, it's not t. It's rather s minus t. Okay, I'm sorry, I made a mistake here. It's s minus t. Okay, please make a correction there. That's what I recall just now. So it will be e power. Oh, first let me write down n square by square e power c times n square by square, and then it will be s minus t into fn of t dt. We know that this value exists for n equal to 1, and this one exists for f3. So since only f3 will be there in the picture, the rest of them will be 0. So I just need to open this bracket for 3 and open this one for n equal to 1. So I'll be getting just d1 sine n by x. So that will be just 5x e power minus of c will be there. So it will be c times pi square t and plus this one will be open for 3. So this one will give me sine 3 pi x and e power c times 9 pi square into s minus t. That 3t is again 1. Okay. So why I forgot this thing? It will be integration from 0 to t. Okay. This will be integrated basically between 0 to t. Okay. So let's find out what it's gonna be. So on the next page, I'll be writing t1, and which is nothing but just sine. Oh, what is it? Pi x. Yeah. Sine pi x and e power minus of, what do I have? C pi square t. E power minus c pi square t plus. I know that this is sine 3 pi x will come down. We don't need it. And in fact, from here, with certain modification, we can see, since we have to deal with fn of s is again 1, right? See, fn of s is again 1 because of this thing. Fn of t is 0, so fn of s is also 0 basically. Okay, so this is what we have to employ here. Okay, and it is 1 with respect to s we are integrating. So there is no role of t. So that what we will do, we will take t term completely outside this integral. So that will give me sine pi x e power minus c pi square t plus sine of 3 pi x, and we can take e power minus 9c, sorry, 9c pi square t. This should be common. Okay, 9 pi c 9 pi square minus t. So I just have to integrate c 9 pi square s. Okay, so into integration of 0 to t e power c 9c pi square s. Correct? 9c pi square s. It will be integrated. So I'll be getting e power minus c times pi square t, and then sine of pi x plus e power 9c pi square t, then sine of 3 pi x, and this integration will be e power 9c, sorry, no, in fact 9 pi square c, that's okay, and then s on 9c pi square integral 0 to t. Okay, so let us substitute. That gives me e power minus c pi square t into sine of pi x and plus e power minus 9c pi square t sine of 3 pi x, and right here I'll be getting e power 9 pi square ct minus 1 on 9c pi square. Okay. So this is my uxt, and that's what the solution is. Okay, so we are happy. We got almost everything here, and now I think there was something more in the question. Yes, we have to find out u of half comma t when limit t tends to infinity. So let's find out u of half comma t. So let me use the next page. So u of half comma t will give me just instead of x, I'll be just putting half. So just let me do a blank calculation here. So u of half comma t will be e power minus c pi square t will be into the picture, and then this quantity right here will give me sine pi by 2 plus e power minus 9 c pi square t, then it will be sine of 3 pi by 2, right? And this entire quantity will remain. Okay, so there is no impact here. Now our goal is to find out this 9 times can be taken common. Okay, all right, no issues. So right here, what do I get? So, see, this quantity to be 1, this minus 1, right? Sine 3 pi by 2 is minus 1. So I write down e power minus of c pi square t, e power minus c pi square t plus minus e power minus 9 c pi square t minus 9 c pi square t into it is sine 3 pi by 2, so that will be 1. Rather I should have taken this thing to down, but no way, no issues. And then this entire quantity e power 9 pi square ct 9 pi square ct minus 1 upon 9 pi square c. I guess this is what we have here, right? Yep. So we happily got this. And let us see what we get here. Okay. So in that case, we'll be getting e power minus of c pi square t, and the best choice would be to take this 1 upon 9 pi square c outside and shift this quantity into the picture, because it will create a trouble for us upon e power 9 c pi square t. Okay, so this is my u of half comma t, and I want limit as t approaches infinity. So I'll be getting limit of u half comma t will be equal to limit t tends to infinity e power minus of c pi square t, and minus will be 1 upon 9 pi square c will be out, and then limit t tends to infinity e power 9 of pi square ct minus 1 upon e power 9 c pi square t. Okay. As this becomes infinity over infinity thing, so one can apply L'Hopital to evaluate this limit, and since there is not much difference, it's like e power x minus 1 upon e power x. If you apply limit x tends to infinity, then you simply differentiate the numerator and denominator to apply the L'Hopital rule, and you get this thing to be 1. Similarly, this quantity also gives me 1. Okay. So I assume that you already know how to solve limit in L'Hopital. This quantity will be 0 because as t tends to infinity, this entire quantity approaches 0. So this will be 0 minus 1 upon 9 pi square c, and right now this quantity will be 1. So my limit would be minus 1 upon 9 pi square c. Okay. So this quantity will be minus 1 upon 9 pi square c. That's what I got. Oh, so we got one more. It says if u of xt is the solution of this heat equation, okay, with non-homogeneous boundary condition. It's homogeneous right now. It's non-homogeneous boundary condition. The rest everything is same. Okay, this is finite, so we will employ the another formula which we have learned. So let's see. For that, we need to make one transformation. Okay, so just let me quickly do this. So in that case, what I consider, okay, so let the solution uxt is equal to some v of xt plus some ax plus b. Okay, we want to make the condition first homogeneous and then we will solve. So for that, I have considered this transformation, and this transformation will help me to give this what I need. So u02 equal to v of 0 comma t plus this quantity will be 0. I'll be getting b, and since we have forced v of 0 comma 2 to be 0 because this is what I need. Okay, then in that case u of 0 comma t they have given 1, so it will be 1 equals to b. Okay, now u of 1 comma t, it will be v of 1 comma t plus a into 1 plus b. B we got 1, u of 1 comma t is given to be 2, and this is 2 equals to, right now this quantity we want to be 0. So when we got v of 1 comma t 0, in that case our a will be 1. Okay, so this is one more, and I need to change the initial conditions to them. So I'll be having v of x 0 plus a is x and b is again 1. So we want u of x comma 0. Okay, so u of x comma 0 is u of x comma 0 is 1 plus x plus sine 2 pi x by 2. So 1 plus x plus sine of 2 pi x over 2 equals to v of x comma 0 plus x plus, right? This is what we know, and now from here we will obtain our initial condition which we need, and so happily one can see that this x and 1 is getting cancelled from both sides, which gives us the immense happiness to write out v of x0 equals to sine of 2 pi x over 2. Okay. So now our problem is modified to oh, one second, I just forgot one thing. Before this line, we have to consider one more thing. So the transformation which we have uxt equal to v of xt plus ax plus b. Okay, since we have everything in terms of u, so we want in terms of v. So del u over del x would be del v over del x plus a. One more time, differentiate. So we get del 2v upon del x2. This one, and then del u over del t will be given by del v over del t. And since there is no t, so everything will be 0. So now our problem becomes del v over del t equals to del square v over del t square with the condition v 0 to is 0 and v 1 comma t is also 0 and v of x comma 0 is sine 2 pi x over 2 sine 2 pi x over 2. And now we know how to solve this equation. I have discussed this in my previous videos. So the solution directly is given by v of x comma t equals summation n equals to 1 to infinity dn into sine of n pi x over l e power minus c n square pi square on l square t. And where this tn thing is 2 upon l integral 0 to l. Now this is no longer I'll be using my f. Here it is g of x, so I have to use g. So g of x into sine of n pi x on l dx. So let us substitute, and the first goal is to find out dn. So let's find out. So dn will be 2 by l. I can see it is 1, so 0 to 1. For those who are wondering how this l is coming from, so you just have to find out the length of x. Between 0 to 1. If it is not given, you just see this. Okay, u 0 to is 1 and u of 1 comma t they have given 2. So it's going like this from at 0 and it is 1. So the length is 1. So one can even get it from here. So let's complete the problem. 0 to 1 g of x. G of x is sine 2 pi x over 2. So sine of 2 pi x over 2 into sine of n pi x dx. Happily I'll cancel this, and this gives me the integral 0 to 1 sine of 2 pi x into sine of n pi x dx. Now to apply our formula, we just need here limit to be pi. So with the same substitution which we have made, I'll be getting this 1 upon pi, then integral sine. This is the substitution that I have made, so it will be 2z to sine of n c dz. So this is my dn. I know that this will exist for n equal to 2, so I'll find out d2. That will give me 1 by pi, and this integration is going to be pi by 2, so I'll be getting half. Okay, so in that case, I got this thing to be half. Now, so d2 I got, and now I need just substitution. So uxt, and yeah, one more thing, and where all of the dn's will be 0 for all n excluding 2, because we got d2 equals to 0. And this uxt will be, since I have d2, so it will be d2 sine of 2 pi x e power minus of n is 2, so it will be 4 pi square t. Okay, and plus the rest of them will be 0, so it will be my one second. I'm sorry, this is v. So v of xt, I got this, and the solution is given by u of xt. Okay, so let's quickly put this d2. D2 I have got half. So let us put half of sine 2 pi x into e power minus of 4 pi square t. Now we have considered the solution is this. So let's call this equation as Now from hash, what we have is uxt equals vxt plus a is 1 and x plus 2. Or have I made any mistake? No, it's x plus 1 only. Okay. B is 1, a is also 1. So it is again 1. Okay. Now vxt we got half of sine 2 pi x and e power minus of 4 pi square t plus x plus 1. That's my u of xt, and it is the complete solution. Okay. And now we need to find out u of 10 comma 10 and u of 9 comma half. So let's find u of 10 comma 10. So u of 10 comma 10 will give me half of sine of, well, luckily we have got here 20 pi e power minus of 4 pi square into 10 plus 10 plus 1. So right now this quantity will be 0 and it will be simply 11. So u of 10 comma 10 will be simply 11. And also we need to find out u of half comma, oh sorry, u of, what is that, 9 comma half. So let's find out u of 9 comma, and u of 9 comma half will give me half, and then sine of, it will be 9 pi by 2 and e power minus of 4 pi square into 1 by 2 plus 9 plus 1. Yeah, is it fine? So 9, I think why I got this here 2. This is wrong, not 2. Okay. Simply 9 pi. Okay, because it is at 9, I thought this half inside 9 pi. This will be again 0 because sine n pi is 0, so this quantity right here will be 0. I'll be just getting simply 9 plus 1, and that gives me 10. So u of 9 comma 1 by 2 is 10. And from here, if you see an important thing, then we can generalize even as a result and write down. See, when I put this effect of t is nil. This t is not making any sense here, because no matter what t you put, this quantity is going to be 0. So ultimate goal is split by these two quantities. So basically you can say that u of n comma t is going to be n plus 1. Simply, the solution is given by this. No matter, in fact, not write down n. It's for any p. Okay. Or p belongs to, yeah, the solution is general solution, most general one. You can substitute anything and find out. Okay. So these were the two problems discussed on the last video. Okay. I'll provide the link of the previous video in my description. Thanks for watching.